Okay, so here is a result from spatial statistics. Given that pi x squared follows an exponential function, an exponential distribution, prove that 2 pi lambda x squared follows the chi-squared distribution, and prove that the mean, the expectation of x, is 1 over 2 square root lambda, and the variance of x equals 4 minus pi over 4 lambda pi. So we're going to first prove the first assertion by proving that x squared, chi-squared with 2 degrees of freedom is equals to the expectation, to the exponential function with lambda equaling 1/2. So this will be our lemma. And how we'll do that is through the CDF method. So we're going to take the CDF of chi-squared with 2 degrees of freedom, which is given by the limit of f towards infinity from negative f towards t to the probability distribution, density function of the chi-squared distribution. So x 2 over 2 times e minus 2 over 2 minus 1 over here times 2 over 2 times the gamma distribution of 2 divided by 2 from with the identity function. And so since it only goes up until from 0, since the support of the chi-squared distribution is only from 0 to infinity, we can disregard the limit. We can disregard values of t below 0, which leaves us, since this equals to 1, this equals to 1/2. Well, we can leave it out of the equation over here. This one turns into 1, and leaving this one over here, dt, which equals to, well, using the chain rule, we'd have to multiply it by negative 2 e negative t over 2 minus negative 0 over 2, which is equals to 1 minus e times negative 2 over t, which is the exponential function with lambda equals 1/2. Now, we are going to use the CDF method as well in order to prove that z, let's take z to equal 2 pi lambda x squared with y equaling pi x squared. We want to get the distribution of f of z, and so by the definition of the CDF, all z less than or equal to lowercase z, since z is equals to 2 lambda y, you just plop this here, less than or equal to z, apply the multiplicative identity, assuming of course that lambda is not negative, which it isn't, we replace the x in the exponential distribution, the CDF, with z over 2 pi lambda I, with the support, of course, z 2 pi, and the lambda cancels out, negative 1/2 times z, and since you could divide all positive real numbers by 2 lambda and it'll still be all positive numbers, you could just simply write this as z, which is the exponential, which is the CDF of the exponential function distribution with lambda equals 1/2. And since z is distributed exponentially with lambda equals 1/2, z is also distributed chi-squared with 2 degrees of freedom. So we've got the first assertion proven. Now we can move on to proving the expectation of x and the variance of x. So how I'm going to do this is by first deriving the probability density function of x. And so we are going to do that by method of transformation. So from x, the inverse of x compared to z is this, 2 pi lambda x squared. And that